Hello, my HBS students. It is Wednesday, April 22nd. I feel like I need to check the day of the week and the date multiple times to try and figure out what day it is. But it is Wednesday, and we are moving on to lesson 7, which is the last lesson in Unit 3.4 about the urinary system and the kidneys. Um, so if you have not yet, please go watch this video that I posted last week on Friday about the expectations and the new grading opportunities and schedules for the distance learning phase 2. I've gotten a couple emails asking me about how to improve their grade from their third quarter grade to their final grade, and all of the answers are in this slideshow or in the video linked there. We are doing our first Google Meet after spring break back together, and we're going to be doing Fridays at noon. So hopefully I will see you this Friday at noon to be able to talk about content. If you have specific grades, like specific to you, specific questions about grades, that is only relatable to you, then go ahead and send me an email. But if you have questions about content or general questions about the class or what's going on, the Google Meet would be the perfect place to come and ask those questions. I also want to try and make it fun. I know we kind of tried to do the show and tell that kind of worked, but maybe on Friday, come prepared with a couple ideas you have of how to make those fun and interactive. So we can share and maybe play a game. We could do Kahoot. We could definitely do Kahoot. Maybe we could do categories. I could project my screen and we could do some categories. But yeah, for the most part, I'm going to be doing all of the lectures and the lessons on Screencastify, and the Google Meets will just be hanging out. So speaking of lessons, we have lesson number 7 that is going to be published right after I finish filming this video. I've been working on it this morning. And it starts with me talking about the nephron a little bit. The nephron function is kind of a tricky concept. And so I do want to kind of just talk through it with you. I have a little video that I embedded in this review slideshow that I think does a good job of talking about it. So we are going to start with that. That's going to be the explore part. And for the explore part of this lesson, I just want you to watch the video and then go back and finish any of the previous few lessons that you haven't, and then put any questions here that you have. So we'll start with that, and then we'll get back to the last little bit of the unit, which is a urinalysis. So let me click over to my slides. I'll present. So when we're talking about the kidney, and you guys hopefully have already done the last few lessons, but the kidneys at any given time are going to hold about 20% of your blood. So that's quite a bit of blood that is constantly flowing through your kidneys. You may have heard of dialysis. We've used dialysis, tubing in some of our labs before, but if somebody's kidneys stop functioning, one thing that they have to do is they have to go through dialysis, where they're going to the hospital, they're getting hooked up to a machine, and that machine is kind of taking the place of their kidneys and filtering their blood and taking out all the toxins and all the things that shouldn't be there, and then putting the blood back into their body. So this little graphic shows the pathway of the blood, and hopefully you remember from PBS that if we're talking about an artery, arteries are going away from the heart, so they're carrying blood with or without oxygen. What do you think? With oxygen. And so it's coming from the heart, it's got oxygen in it, it's going out the aorta, renal artery, and then to the afferent arterial. So I always remember afferent and efferent. A becomes before E. So we have the afferent arteriole going into the glomerulus, right? We'll see that on the next slide. But the glomerulus is that ball of yarn. And then we're going through filtration and reabsorption and excretion and all of that. But the blood flow continues from the glomerulus and then out the kidney through the efferent arteriole, then the renal vein. Veins go back towards the heart, and then inferior vena cava, and then back to the heart. So this is kind of the pathway of the blood as it's going through to and from the heart and the kidneys. So I think 2 lessons ago, you guys looked at kidney dissection. I'm so sad that we didn't get to dissect the kidneys together because they actually are quite pretty. Not a very intense dissection because you just cut it in half. But when you open it up, you see this kind of rich tissue and you see those distinctive pyramids and you see the kind of tough capsule on the outside, and you see the difference between the cortex, right, the outer layer here, and then the darker medulla where you would find these pyramids and the columns. So that's one thing that gets confused a lot is that in the medulla, so this whole bracketed section right here is the medulla, and within the medulla you would find the pyramids, right, the darker triangle areas, and then in between the pyramids are the columns. And then the cortex is going to be this outer. If you saw the pictures or took the quiz, it's kind of typically a little bit darker brown color is that outer cortex. And where this becomes important is when we're talking about the nephron. So the nephron, obviously, during the dissection, you wouldn't be able to see the nephron. They're tiny, tiny, tiny. You have millions of nephrons inside each of your kidneys, but the nephrons is where the magic happens, right? This is the functional unit of the kidney. This is where we are producing urine. And you can kind of take the mouse and you could draw a straight line across right here. And you could say that if I'm zooming in on this area, right, the glomerulus and the Bowman's capsule are going to be found in that outer cortex area. And then dipping down into the medulla, into this darker area right here, and to the pyramids, are going to be that loop of Henle and the collecting duct. So I think that was a quiz question. But the glomerulus and the Bowman's capsule are going to be on this cortex area, and then you would see, if you could see the nephrons dipping down into the medulla would be the loop of Henle and the collecting duct. So that's a little orientation for you. So you all already should have in the last lesson, and I love watching or getting back your drawings. I know I've kind of asked you to do a lot of sketching and drawing because we're not printing diagrams for you, but you guys have been doing a really good job of following along and doing your drawings. And this was a sketch notes video that talked you through the steps of the nephron and how we go from filtration to excretion. So we'll look at this in a second, but I want to go back to this video. Okay, fair warning, this video is an animated video with a voice that's just a computer voice. So I'm going to let it play and then pause it and kind of give you my 2 cents as we go. So let me click over here. Hopefully you can hear this. Okay. Ready. Okay, so right there was a question from one of our previous lessons talking about kind of the order of events going from the kidney to the ureters, the holding the urine in the bladder, and then excreting through the body through the urethra. So kidneys, ureters, bladders, urethra. Oh, look, there's my favorite little adrenal glands, little kidney hats. Okay, so if I pause it right there, you can see what I was talking about, where the glomerulus and the Bowman's capsule and part of the PCT, the proximal convoluted tubule, is going to be up here in the cortex, and then dipping down into the medulla is going to be that loop of Henle and the collecting duct. Okay, so this is going to become important is the thickness right here. So descending, meaning going down. So the descending side of the loop of Henle is a little thinner, and then it does this hairpin turn, comes up. You have a thin section first, and then you have a thicker section of that loop of Henle. And this loop of Henle is going to come into play, and this is probably the most confusing part about the nephron. So we'll look at that in just a second. Okay, so that's what we're going to look at in the next few minutes or so, and then that's also what we drew on the sketch notes. So we go from filtration to reabsorption to excretion, and that all happens kind of right here. So they pulled out the diagram so it's less confusing to look at, and now we're going to see what happens along each stage. Okay, so whenever you see this red arrow, right, that's going to be active transportation. And active transportation, remember, requires energy. So that means it's going to be some sort of a pump. Okay, black arrow, diffusion, means that it's passive and does not require energy. And you're going to see this kind of pairing right here with the sodium chloride and the water throughout this loop of Henle. Okay, so that's talking about how that question, I think it was the last lesson where we were looking at the glomerular filtration rate, right? If we excreted all of the water that we drank, right, or if we excreted all of the water in our filtrate, then we would be constantly dehydrated. And so your body has to balance and figure out how much water can I excrete and how much water do I need to keep. And you've seen this direct relation with the color of your urine, right? If you're more hydrated, you're drinking lots of water, then your urine is going to be more clear. If you're not hydrated and you're not drinking enough water, then your body's going to hold on to more of that water, which is going to concentrate your urine, which is going to make it a deeper, darker yellow color. So we want our urine to be that light pale yellow. Ooh, counter current multiplier. That's a really good description of what's going to happen because counter current meaning that it's working backwards. Okay, so this side, the thick ascending part, is actively pumping out sodium. The chloride kind of hitches a ride. It's actively pumping out sodium, but this section, this thick ascending limb, is not permeable, right? It does not allow water to come out. So the water has to come out somewhere else. Okay, there we go. So kind of the test questions that I would have asked if we were in school would be talking about the permeability on each side. So the descending limb is permeable, right? Allows water to leave and be reabsorbed. And then the ascending limb going up is actively pumping out and reabsorbing sodium chloride. And so that is what's making the concentration. So the active transportation um, or active reabsorption of the sodium chloride on the ascending is allowing the descending side to reabsorb the water because that's where that side is permeable or allows water to escape. So that's why it's countercurrent, right? The descending side is affecting the ascending side is affecting the descending side. Okay. So that's kind of the take home that I wanted you guys to be able to see is that we already know that the loop of Henle is its job is to do the concentrating of the urine, but this is how it's working. It's working through passive and active transport. It's pulling out the sodium on the ascending side and the water is following on the descending side. And it's all due to the difference in permeability. So hopefully that helped a little bit. Let me go back to the sketch that you guys drew. The next one, yep. So here's the sketch that you guys drew, and I just put a little bit of notes there, and I'll link this review slideshow too, so you can see it. And again, kind of the take homes, the test questions that I would ask is where are these main functions happening? Filtration, right, is going to be here in the glomerulus is going to be filtrating the stuff that we don't want in our urine. It's going to be collected by the Bowman's capsule. So our filtrate is happening here. The main bulk of our reabsorption is going to happen during the in the PCT, right, the proximal convoluted tubule. You can see right here that we're reabsorbing potassium, water, amino acids, glucose, bicarbonate, sodium chloride. We're reabsorbing all of this stuff here. We want to get rid of, right, secrete means we want to get rid of it. We're going to get rid of some uric acid, some organic acids as we go along. Then as we go through the loop of Henle, we're reabsorbing some more, again, sodium chloride on this side, water on this side, and concentrate in the urine. And then the last little bit is kind of the fine tuning. So the DCT is the fine tuning, taking out the rest of the sodium chloride that we need, the water that we need to hold on to, getting rid of some potassium and some hydrogen. And so this is the fine tuning. And then finally, during the collecting duct, this is the excretion. So this is what we start with, right? Filtration is what we start with. Oh, I can use my pointer. Filtration is what we start with. Excretion is what we get rid of. And then everything that we reabsorb on the way stays in our body. And that was another point from our last lesson, was the creatinine is the marker of your glomerulus filtration rate, which you can see is the only thing along the way that goes from start to finish, right? Right here, creatinine, and then right here, creatinine goes from filtrate to excretion without being secreted or reabsorbed along the way. So we use that. They gave us, in the sketch notes, they gave us a formula. They said 90 milliliters per minute divided by the, like, your surface area. So your 1.73 meters squared. So based on your height. But I believe in our activity, they used 125 milliliters per minute, and then you had to do the math with that. But yeah, so the other two things that I wanted to talk about from our previous lessons, I know this is a long video already. Good thing it's on YouTube and you can do it 2 times speed and hear me quickly. But the other two things I wanted to loop back to are our hormones that we talked about. We've talked about ADH already, which is the antidiuretic hormone, and that's working on the collecting duct. And then the new one is aldosterone. So you did some research on this for the last lesson, but if you haven't, here it is. And if you did, go back and check, make sure you're right. So the aldosterone works on the DCT. And these are feedback loops, just like we've looked at with insulin or insulin, or why am I blanking? I'm blanking. Anyways, looking at feedback loops increasing or decreasing based on the stimulus. So here is a side-by-side of how each of those work, right? So ADH is going to be produced in the hypothalamus, so up in the brain, but it's secreted by the pituitary, right? The hypothalamus kind of is the head honcho. It's controlling everything. The pituitary gland is going to take signals from the hypothalamus and say, okay, go ahead and secrete this antidiuretic hormone, and it's triggered by the osmolarity, so that concentration that we talked about. So if there is either two things, it's either triggered by high solute, so lots of stuff, lots of salt, or by low volume, you're not drinking enough water. So either of those are going to trigger that antidiuretic hormone to kick in and say we need to hold on to more water, either because we have too much solute or because we don't have enough water. So it's triggered by either the increase of solute or the decrease in water. And where it works, again, if we flip back to the last slide, we're expecting that ADH to work on the collecting duct. So it increases the water permeability to the collecting duct, opens up those water channels, and it controls water absorption in that collecting duct. Now, aldosterone This is not in the brain. This is produced and secreted in your adrenal cortex, so those little adrenal glands sitting on top of your kidneys. It is triggered by the decrease in blood volume or blood pressure. So you're either dehydrated or maybe you have some sort of blood loss, right? So that's where aldosterone is going to kick in, and it's going to affect the DCT, that distal convoluted tubule, and it works with sodium. So it kind of goes backwards and says, okay, if we want to increase or hold on to more water, we're going to reabsorb more sodium because we know that where sodium goes, water is going to follow. So it increases the reabsorption of sodium in the DCT, which allows the water to follow the sodium. So those are the two hormones that we looked at last lesson in our sketch notes, and you should have answered some questions about them. So go back and check if you've already done that lesson. If not, you just got the answer. So hopefully you're watching this and following along. All right. This is a really long video, and I'm sorry. But now we got to look at, that's just the review part on Explore. For the explain, now we're going to look at the urinalysis. So if I have somebody who is sick and they come in and we test their urine, right? Urinalysis is a very quick and easy way. It's non-invasive. You're just peeing into a cup. And you can get a lot of information about somebody's health through a urinalysis. And it's can be done usually right in the doctor's office. And I linked some notes for you. So take a look at these notes. You can copy them down in your notebook if you want to, but otherwise just use those notes to answer these questions about kind of the different steps to a urinalysis. What does it mean when you find different things in the urine? And then for the apply, I've got case studies. So I have 6 case studies. 6 different patients come in. You get a little paragraph about them and why they're there to see you and why they're getting urinalysis. And then because we're not together, I went ahead and filled out the data for you. So this is the data that you would have collected if we were all together and doing this lab in class. What you need to do before you look at this data is you need to do some research and figure out what is normal, right? What is a normal pH? What is a normal specific gravity? And you can use the notes that I gave you. I also linked a couple reliable sources right here that you can go and use those as well. So you're going to have to research what is normal for all of the lab results, compare them to what I gave you for each of the case studies, and then give me your diagnosis. So how would you diagnose each of these 6 patients based on the paragraph in the case study and the lab results that I gave you? And be sure to support your diagnosis with at least 3 pieces of evidence from either the case study or the lab results. And that's it. Lesson 8 will come out on Friday, and it's going to be your essential skill of this unit for water. So look out for that for lesson 8 on Friday. And if you've been following along, that means that if you finish 1 through 8 and it's all complete, then you could get a 3% grade increase right there. So I'm sorry this video was so long, but I hope to see you guys on Friday at our Google Meet at noon. I'll put the link right here, also post it on Schoology, and I hope you guys have a good week. Bye.